Hi, I'm Tim, and I'm here to tell you what happens when you taste food, and how your brain converts this steaming hot pocket in front of me to the delicious, yummy snack that my taste receptor sense when I put it in my mouth. Then we'll talk about what you can do to keep your mouth in tip-top condition to continue feasting on your favorite treat. But now, I get to eat my hot pocket. So as soon as I take a bite, all the sensory information in there is quickly sorted by the 10,000 or so taste buds covering my tongue, mouth, and upper throat. Most taste buds are packed deep down between your fungiform papillae, those little projections that make your tongue kind of rough. You can actually see them if you look in the mirror. Those papillae are not your taste buds. They are actually tucked into tiny pockets hidden behind the stratified squamous epithelial cells on your tongue. Each taste bud has between 50 to 100 taste receptor epithelial cells which register and respond to different molecules in your food. Notice that these are specialized epithelial cells, not nervous tissue, so they still have to synapse to sensory neurons that carry information about the type and amount of taste back to your brain. There are actually two types of epithelial receptor cells, and the first type is gustatory, which actually does the tasting, and the second being basal, which are the stem cells that replace the gustatory cells after I say, take an ambitious bite out of my hot pocket right after taking it out of the microwave. Basal epithelial cells are great because they can replace your gustatory cells every week or so, which means that even if I have a terribly burned tongue, then my tongue will feel a lot better after a couple of days. Every gustatory cell projects a thread-like protrusion of the cellular membrane called a gustatory hair, which runs down the taste pore, a small hole in the stratified squamous epithelium covering the taste bud and the rest of the tongue. Chemicals called tastants from this delicious hot pocket I'm eating dissolve in saliva so they can diffuse through these taste pores and bind to receptors on those gustatory cells, and then they trigger an action potential. Each tastant is sensed differently. For example, my hot pocket is salty and full of positively charged sodium ions that cause sodium channels in the gustatory cells to open, which generate a graded potential and spark an action potential. A warhead candy, for example, is sour tasting and acidic, high in hydrogen ions, and take a different route by activating proton channels. So taste, like all our senses, is all about how action potentials are triggered. Once an action potential is activated, that taste message is relayed through the neurons via cranial nerves to the taste area of the cerebral cortex in your brain. One theory of how your body indicates what type of flavor you are tasting is called the labeled line theory. This means that we have one type of taste receptor that detects one kind of taste, like the salty flavor of my hot pocket, and this receptor sends its specific impulse to only one sensory neuron in your brain. So, I've eaten my hot pocket. What can I do to make sure that I can keep tasting this delicious snack when I want it 20 years from now? A recent study shows that people with decayed teeth, poor oral health, and oral bacteria in their mouth had difficulty in detecting sweet and salty taste. Sour taste especially was impaired in patients with high growth of oral bacteria. Things like brushing our teeth 2 times a day, flossing, eating healthy snacks, perhaps not too many hot pockets, going to the dentist at least yearly, and drinking water instead of soda help us in maintaining proper oral hygiene. Keeping teeth healthy is important to keep teeth strong, to clean food out from our mouths, and to keep germs from going into the rest of our body. Thanks for joining me, and I hope you'll come back next time.